Hello everybody. Today we're going to talk about solving compound inequalities. Compound inequalities are two inequalities that are graphed on the same number line. We have two major types of compound inequalities, or two types I should say. We have or statements and we have and statements. It's very easy to distinguish between these two types. Or statements will always say the word or. So we'll have an inequality, the word or, and another inequality. For or statements, we want to keep all possible answers. So no matter what happens, we're going to keep all possible answers. But typically, when you graph or statements on a number line, they will diverge or go in opposite directions, just like this little image I have at the bottom here. So typically, when you graph them, they will diverge or go in opposite directions. But that won't always happen. Sometimes they will actually overlap. But regardless of what happens, we keep all possible answers because we're saying we'll either take these answers or these answers as the answer to the inequality. Now an and statement, going over here, we keep only where they have the same answers or intersect. Now an and statement might be an inequality with the word and in between and another inequality, or they'll actually have two inequality symbols in the same problem. Okay? So again, for an or statement, we're going to keep where they have the same answers or intersect. So we're only interested where this inequality intersects or have the same answers as this inequality. Okay? Now typically, and statements overlap or intersect in between the two values, but that isn't always the case. But regardless, they have to have the same answers for it to be an answer to an and statement. So let's do two examples. So first we're going to start with an or statement. So we have 2x minus 5 is less than negative 11, excuse me, or negative 3x plus 14 is less than or equal to 8. So what we do is we solve each inequality and we graph our answers in the same number line. So over here I would add 5 to both sides. So we get 2x is less than negative 6. We'll divide both sides by 2. So x is less than negative 3. Over here, we solve this inequality respectively. So we subtract 14 from both sides. So we have negative 3x is less than or equal to negative 6. We'll divide both sides by negative 3. So x is greater than or equal to, because we have to flip the signs, we divide by a negative number, positive 2. So for this first inequality, we put an open circle at negative 3 and we shade to the left. We only want numbers less than negative 3. For this one, we put a closed circle at 2 and shade to the right. We're only interested in numbers greater than 2. So our final answer for this compound inequality are both numbers less than negative 3, but also numbers greater than or equal to positive 2. Okay? Now an and statement. An and statement will either say the word and between our two inequalities, so it'll look just like this, but it would say the word and right in this area right here, or it'll look like this problem where we have two inequality symbols and one inequality. So what I like to do is I like to draw some dotted lines through the inequality signs, and the reason why is for a compound and statement that's written with two inequality symbols, we actually have three sides to the problem. So if I want to isolate this x or this 3x first, I'm going to add 8 to both sides. But instead of doing it to both sides, we actually do it to all three sides. So we'll work our way left to right. We have positive 3 is less than 3x, which is less than or equal to positive 9. We'll divide both sides by 3 to isolate the x. Actually, we're doing that because of this x in the middle. So we have 1 is less than x, which is less than or equal to 3. So this is our final answer, but we do have to graph it. Now, what I'm going to do is I'm going to break this apart for a second, just to show you what an and statement means. Here we actually have one inequality. Okay, so if I rewrite that over here, putting the variable first, it'd actually be x is greater than 1. So if I'm graphing that, it would be a open circle at 1 and shade all numbers greater than 1 to the right. The second one, and then my variable kind of goes with each one here, my second equality is actually x is less than or equal to 3. So if I graph that, I would put a closed circle at 3 and shade all numbers less than 3 to the left. So kind of look at that right now and ask yourself, where do those two inequalities have the same answers? Because for an and statement, our final answer or our answer is only where they have the same solution set. Well, these two graphs intersect or have the same answers between numbers greater than 1 and numbers less than or equal to 3. So this is actually our answer. So I just wanted to graph each one to show you what an and statement means, but we don't actually want these other graphs. We only want the area in between the two graphs for our final answer. And you can kind of tell that right here if I rewrite the final answer from before. Basically what this is saying is our solution set is between numbers greater than 1 and numbers less than or equal to 3. So it's basically between these two values. Okay? So there is a brief lesson on compound inequalities. We did one or statement and we did one and statement. This should help you get started and get you familiar with these. If you have any questions in class, please let me know. Thank you very much for your attention and have a fantastic